Hello everyone. In this video, let's talk about solutions to 2021 AMC10B. Let's start from question 1. How many integer values of x satisfy that its absolute value is less than 3 pi? Let's roughly estimate 3 pi. 3 pi is approximately 3 times 3.14, and this is approximately 9.42. So we need to have x satisfy the following. X must be between negative 3 pi and less than 3 pi. So x should be larger than negative 9.42 and less than positive 9.42. And here we'll only consider integer values. So x could be integers from negative 9, negative 8, up to negative 1, 0, 1, 2, up to 9. So they are totally 19 numbers. So the answer to question 1 is 19. Question 2, we need to find the value of following expression. We have square root and a square. So basically they cancel each other, resulting in an absolute value. So this equals 3 minus 2 root 3 absolute value. That's for the first part. The second part is 3 plus 2 root 3 absolute value. And we know 2 root 3 is larger than 3. So the first expression equals 2 root 3 minus 3. And the second expression is positive 3 plus 2 root 3. So we cancel 3. We have 4 root 3. The answer is D, 4 root 3. Question 3. In the after school program for juniors and seniors, there's a debate team with equal number of students from each class. And among these 28 students in the program, 25% of the juniors and 10% of seniors are on the debate team. How many juniors are in the program? So here we have the total number 28 in this program. Some are junior, some are senior. Let's assume we have junior student X, and accordingly, senior student should be 28 minus X. And next, we have 25% of junior students join this debate team, and 10% of the senior student join this debate team. The problem says that we have equal number of students from each class. That means these two numbers are equal. From here, we can solve the value of x. On the right, this equals 2.8 minus 10% x, and we have 35% x equals 2.8. So x equals 2.8 divided by 35%, and we'll have number 8. So 8 is the solution. We choose C. Question 4. We have 57 students wearing blue shirts. And 75 students wearing yellow shirts. And now they are assigned into 66 pairs. There are 23 of these pairs. Both students wear blue shirts. Let's call this to be blue pair. We have blue pair. There are 23 pairs. That corresponds to 46 students. So totally we have 57 blue shirts. So 57 minus this 46, we have the remaining 11 blue shirts. And for those 11 blue, they are paired with yellow shirts. So we must have blue, yellow pairs. There are 11 pairs. That comes from here. So from here, we have 11 yellows. Totally, we have 75 yellows. So 75 minus 11 equals 64 yellow shirts in yellow pair. So the number of yellow pair is 64 divided by 2 equals 32 yellow pairs. So the answer here is 32. Question 5. We have 4 ages. 2 of them multiply to get 24. The other 2 multiply to get 30. These 4 numbers are disjoint. They are different numbers. So let's factor 24 into a product of 2 single-digit number. This corresponds to either 4 times 6 or 3 times 8. There are only 2 ways to factor 24 into this product. And 30 equals 5 times 6. That's the only way to factor 30 into the product of 2 single-digit positive number. But these 4 numbers are disjoint, so we must have 30 equals 5 times 6. So 6 cannot appear in the factorization of 24. So this is invalid. We should take it 3 times 8. So the 4 numbers are 3, 8, 5, 6. The sum of these ages equals 22. So answer is B. Question 6. We have 2 classes, the morning class and the afternoon class. In the morning class, the average of the score is 84. The afternoon class average, the mean score is 70. And we know the ratio of students in these 2 classes as 3 to 4. Let's denote morning class, we have 3K students. And the afternoon class, we should have 4K students. And the mean in the morning class is 84, and the mean in the afternoon class is 70. Now the average, the mean of the score for all students, that's the total score over total students. The total score is the scores from morning class, that's 3K times 84, and the scores from afternoon class, which is 4K times 70. The total number of students will be 3K plus 4K, which is totally 7K. This equals 532K divided by 7K. So actually K does not matter here. The answer here equals 76. So we choose C here. Question 7. On the plane, we have a straight line L. And there's a point on the line called A. There are 4 circles. Their radius are 1, 3, 5, 7, all of them tangent at A. We consider the set S consists of all the points that lie inside exactly one of the 4 circles. Because we have 4 circles tangent at one point, there are only 2 sides, so some small circles should lie in some big circle. And the small circle's area should be subtracted. In order to maximize the area of region S, we must separate the largest 2 circles, 2 largest circles, radius 7 and the radius 5. So we place them on 2 sides. So this is radius 7. And we should put the radius 5 on the other side. Next, the small circles, or with radius 1 and with radius 3, they must lie in those 2 one of these two, one or two of these two circles. To minimize the error to be subtracted, we can do the following. We place the circles with radius 3. And then the circle with radius 1 inside of the circle with radius 3. In this way, we only need to subtract the area of the circle with radius 3. So the answer here will be pi times 7 square minus pi times 3 square. We don't need the minus pi times 1 square because that's already included in the blue circle. And we plus pi times 5 square. So this is 49 minus 9 plus 25 gives 65 pi. So the answer here is 65 pi. Question 8. So we put the numbers from 1 to 225 into a 15 times 15 grid, starting from the center square. Basically, we place number in the format of the spiral, clockwise spiral. So start from 1, 2, 3 to here. So you see that for the center, say 3 by 3, on the upper right corner, this is 3 square. Similarly, for the center 5 by 5, on the upper right corner, this corresponds to 5 square. So if we look at this diagonal, it's 1 square, 3 square, 5 square. Next one should be 7 square and 9 square. So let's see, what's the largest square in the circle, okay, in the spiral before we reaching the second row. So that corresponds to 11 by 11 square. So this is 11 by 11 square. That means on the upper right corner, this is 11 square, so 121. This number is 121. Following this pattern, we go to next here and downward here and here. So we start to reach the second row in this way. Here we need to find the sum of the greatest number and the least number on the second row. So that means we need to find the first number appear in the second row. And the last number appear on the second row. So obviously we have this is the first number appear in the second row. If we still look on the right upper corner, we will have 13 square here, which is 169. So if we turn back by 12 squares, we turn back by 12 steps, we get this number. The first number in the second row, which is 169 minus 12 is 157. So the number here is 157. And then let's see which number appears, which number's last number appear on the second row. Following this pattern, we will have the following path of writing numbers. The last number is 225. And we note that the last number on the second row is the number exactly on the left of 157. So still we can start from 225 and then turn back. Turn back by 15 steps. That gives you 210. So the last number on the second row, which is the largest number, would be 210. So the question here asks the sum of these two numbers. So we have 157 plus 210 gives 367. The answer here is A. Question 9, on the coordinate plane, we have PAB. It's first rotated counterclockwise by 90 degrees. So we get a new point. This is around the point 1,5. And then reflect this point about the line y equals negative x. The image of P of these two step of transformation is negative 6, 3. What is B minus A? So let's go reversely. So we turn back. First, we reflect negative 6 and 3 by about this line y equals minus x. So it will go to the value minus 3, 6. This point is the result after one transformation. And then we should go backward again by rotating this point about the point 1,5 by 90 degrees. But this time we should do clockwise. Let me mark the point 1,5. This is 1, this is 5. We rotate the point about 1,5. Let me call the resulting to be P3. This is P2. So we want to get back to P. We rotate P2 about 1,5 by 90 degrees. So let's draw this right triangle. We call this 1,5 to be A. Now we rotate this triangle 90 degree clockwise. We will have the following triangle. And the corresponding point P is here. That's to be determined, PAB. So here we have the triangle. Let me call this B, PAB, P2AB, P2B equals 1, because 6 minus 5 equals 1. AB equals 4. 1 minus negative 3 equals 4. If we call this is the image of B equals C, we will have little b equals the y coordinate of A plus the length of AB, which is 5 plus 4 equals 9. Now A is the x coordinate of P. It should be the x coordinate of A, which is 1, plus the length of P2B, which is just PC. P2B equals 1, so A equals 2. In this way, we find the original point, P. And we can solve B minus A equals 9 minus 2 equals 7. The answer is 7 here. Question 10. We have an inverted cone with base radius 12 and height 18. It's filled with it's full of water. So we know the volume equals 1/3 pi times 12 square. Pi 12 squared, that's the area of base, and times the height, that's the total volume. So we pour this water in a cylinder with base radius 24. This is supposed to be a fat cylinder with radius 24. Suppose the height is h. V equals pi times 24 square times h. And these two volume are equivalent. They are equal. So we have 1/3 pi times 12 squared times 18 equals pi times 24 squared times h. We need to solve h. h equals 12 squared times 18 times 1/3. Divide by 24 squared. We can simplify this to get 1.5. So the height equals 1.5 a. Question 11. So grandma finished baking a large rectangular pan of brownies, and we want to cut this into equal-sized small rectangular pieces. So we want the number in the interior pieces is equivalent to the number along the perimeter of the pan. So we can assume, like, on horizontally, we cut into n pieces. That means we cut this into n pieces. And vertically, in this way, we cut into m pieces. Now let's count two numbers. The first number is the pieces in the interior of the pan. Interior of pan means all the pieces within this smaller rectangle. We will have m minus 2 times n minus 2. And next, we count the number of pieces along the perimeter. Along the perimeter, the number of pieces equals 2m plus 2m minus 2. 2m means these two lines, we have 2m. So the other two pieces, we get m minus 2 times 2. So the number here is 2m plus 2n minus 4. So we require these two numbers to be equal. M minus 2 times n minus 2, this equals mn minus 2m minus 2n plus 4. We require this to be equivalent to 2m plus 2n minus 4. That means m minus 4m minus 4n plus 8 equal to 0. So we can factor this into m minus 4 times n minus 4 equals 8. So next we discuss how many ways to factor 8 into product two numbers. So there are basically two cases. Let's assume m minus 4 is smaller. So it's 1 times 8, 2 times 4. So we only have these two cases. So next one would be 4 times 2. That's equivalent to this 2 times 4. So if it's 1 times 8, we get m equals 5, n equals 12. The total number here is 5 times 12 equals 60. We have 60 pieces. The other case, if m minus 4 equals 2, n minus 4 equals 4, This gives you m equals 6, n equals 8. Here we get 6 times 8 is 48. This problem asks the largest, the greatest possible number of brownies she can produce, which should be the first number, 60. The answer is D here. Question 12. We are given a big number n. We want to find the ratio of the sum of the odd divisors to the sum of the even divisors. So let's first write n in the prime factorization in the standard form. N equals 34, which is 2 times 17. Also 2 times 17 again. We have 63. 9 times 7, 270. That's 10 times 27. 10 is 2 times 5. 27 is 3 cubed. This is equivalent to 2 cubed times 3 fifths times 7 times 17 squared. Right here, we consider the odd divisors and the even divisors. The prime number matters here is just 2. If we have 2, it's even. If there's no 2, it's odd. Okay. So for any odd divisor, we just multiply a power of 2. It will give you an even divisor. For any odd divisor, let me call it D, we can consider all even divisors. That's a multiple of D. So here we only consider it's an even multiple of D. Let me say an even multiple of D by adding a power of 2. By multiplying the power of 2. They are following 3 cases. So either 2D, 2 square D, 2 cube D. We have 3 cases. Okay, it's independent of 3, 7, 17. So we here will only consider if we multiply by 2, a power of 2, or not multiply by power of 2. So this applies to any divisor, any other divisor D. Now, this ratio is D over 2D plus 2 square D plus 2 cube D. This is 1 over 14. So the ratio here is 1 over 14 if we consider any specific odd divisor. And this ratio is the same for any odd divisor. So if we sum up all the odd divisors, it would like D1 plus D2 plus D3. We have dk. The corresponding even divisors will be 14D1, 14D2, 14D3, 14dk. The ratio is always 1 over 14, 1 to 14. So the answer to this question is C. Question 13. Let n be a positive integer and d be a digit such that 3 to d in base n equals 263. So this is the equation on d and n. 3 to d with base n equals 263. That means 3n squared plus 2n plus d. This is the value on the left-hand side. It equals 263. And next, the value of 324 in base n. Equals the value of 11d1 in base 6. This gives us another equation. So 3m squared plus 2m plus 4, that's the value on the left-hand side. And on the right-hand side, this corresponds to 6 cubed plus 6 squared plus d times 6 plus 1, which equals 253 plus 60. So we have two equations and two unknowns. We can definitely solve A and D. Let me call this equation 1, this equation 2. Let's do the following. 2 subject 1. This gives, we cancel 3n squared, 2m. We only have 4 minus d on the left-hand side. On the right-hand side is 253 plus 60 minus 263, which equals 60 minus 10. From here, we have that 7d equals 14. So we can solve d equals 2. Next, let's plug in d equals 2 to either equation. Let's take equation 1. We can solve n here. 3n squared plus 2n plus d equals 263. That means 3n squared plus 2n minus 261 equals 0. This is a quadratic equation on n. And we can see this can be factored into n minus 9 times 3n plus 29 equals 0. And n is positive because it's digit, and it's non-negative digit. That means n must be equal to 9. So finally, we can have m plus d equals 9 plus 2 equals 11. So the answer to this question is 11, we choose B. Question 14. 3 equally spaced parallel lines intersect a circle, creating 3 chords with length 38, 38, and 34. What's the distance between 2 adjacent parallel lines? Here, the key is that we have 2 chords of the same length. They are 38. Recall that for a circle and a chord, this is center. Suppose this is the radius, r. The distance from center to the chord, let's say it's d. This d and r determines the length of the chord. The length of the chord should be r squared minus d squared, square root, times 2. And now we have 2 chords of the same length. They must be on 2 sides of a diameter. And they have the same distance from the center of the circle. So let's draw this picture here. This is the center O. We should have these two 38 on 2 sides of the center. And they have equal distance from the center. Say, suppose the distance here is x. This is x. So this corresponds to two lines. We have a third line. Also, we keep the same distance. So the distance from the third line to one of these two chords is 2x. Here. So the equal distance equals 2x. Here we connect the center and the midpoint of the chords and one endpoint of the chords. The radius is r. This is for the chord with length 38. And similarly, for the chord with length 34, we do the same thing. We connect O and the midpoint of chords, and we connect this one endpoint of the chords. Still, we have this is the radius. The distance from O to this shorter chords equals 3x. X plus 2x equals 3x. And half of the chords are 19 and 17. So 38 divided by 2, 19. 34 divided by 2, 17. Here we have two right triangle. We can apply Pythagorean theorem. In the right triangle, we have r here, this is 19 here, this is x here. So r squared equals x squared plus 19 squared. Similarly, on the blue right triangle, we have r, the hypotenuse. One leg is 17, the other is 3x. This provides another equation on r and x. Now both of them equals r squared, so they are equal. They are equal, so we get an equation. X squared plus 19 squared equals 9x squared plus 17 squared. Which means we have 8x squared equals 19 squared minus 17 squared. So this is the difference of two squares equals 19 minus 17 and 19 plus 17. So we have x squared equals 2 times 36 divided by 8. This gives 9. And so we can immediately solve x equals 3 because it's positive. Now the common distance is what we want. The distance is 2x, which equals 6. So the answer to this question equals 6. Question 15. We are given a equation on x plus its reciprocal equals root 5. We are required to get a value of a polynomial expression. Now, a common strategy for such expression is to take square. If we take square on both sides, we have x plus 1 over x squared equals 5. So this corresponds to, on the left-hand side, this is x squared plus 2 times x times 1 over x, which is 2, plus 1 over x squared. This equals 5. That means we have x squared plus 1 over x squared equals 3. And again, we can take another square. X squared plus 1 over x squared equals 3 squared, which is 9. That means x fourths, again, we have 2. The product equals 2. Twice x squared times 1 over x squared is 2. Plus 1 over x fourths here equals 9. That means we have x fourths minus 7 plus 1 over x fourths equals 1. Here we have similar coefficients to the polynomial in the problem. We can multiply, because x is not 0. It's in the denominator, x is not 0. we can multiply both sides by x7. It is still 0. And this can be simplified to x11 minus 7x7 plus xq equals 0. That means the value of the polynomial expression in this problem equals 0. Question 16. We call a number a positive integer an uphill integer if every digit is strictly greater than the previous digit. So it's increasing from left to right. How many uphill integers are divisible by 15? Note that 15 equals 3 times 5. N is divisible by 15. This is equivalent to N is divisible by both 3 and 5. Now, N is divisible by 5. There are only two cases for the unit digit. It's equal either 0 or 5. In this problem, we consider positive integer, and the digits is increasing. That means the unit digit is the largest digit. So if N is uphill, that means the unit digit is the last digit, and it cannot be 0. So here we must have a unit digit to be 5. And N is positive, so the unit digit must be 5. And that's sufficient to guarantee the number is divisible by 5. Next, we need to guarantee the number is divisible by 3. So N is divisible by 3. We must have the sum of digit divisible by 3. So here we can only choose digit 1, 2, 3, 4, sum of them on the left of 5. And once the numbers are selected, the uphill number is uniquely determined. So let's see, we have a digit 1, 2, 3, 4 to be selected. 5 has to be selected. We note that 5 has remainder 2 when divided by 3. So we need to find some more digit, some more numbers. So the sum is divisible by 3. So except 5, the remaining number has digit, the sum has remainder 1 when divided by 3. Some are selected with sum has remainder 1 when divided by 3. That's the requirement. Now let's check each number here. So 1 has remainder 1 when divided by 3. 2 has remainder 2 when divided by 3. And the 3 is divisible by 3. So 3 doesn't matter. So we can choose 3 or not to choose 3. So this is totally free. Let me call this 3. It has two choices. We can either include 3 or not include 3. And now let's consider 1, 2, and 4. 4 also has remainder 1 when divided by 3. So there are following 3 cases for 1, 2, and 4. the sum has remainder 1 when divided by 3. Either we just choose 1, because we need the sum to have remainder 1, so we choose 1, or we just choose 4, or we choose 1, 2, 4 altogether. So there are 3 choices. That means totally we have answer equals 2 times 3 equals 6. Because in any case, we can include 3 or not include 3. So we have 6 up here numbers divisible by 15. The answer here is 6. Question 17. We have 10 cards with numbers from 1 to 10 and 5 people. Raven, Oscar, Aditi, Tyrone, and Kim, each of them pick 2 cards. We add these numbers in each person's, so we get 5 numbers, 11, 4, 7, 16, and 17. Let's try to solve each person's numbers. Now, it's better to it's convenient to start from the smallest number. Basically, we split each number into 2 different numbers, and among these 10 numbers, they are not repeated. So we start from 4. 4, we split 4 into 2 distinct numbers. There's only one way to do that, which is 1 plus 3. We cannot have 2 plus 2 because 2 can only be used once. So Oscar has cards with number 1 and 3. And next, we consider Aditi. So Aditi's number is 7, so we split 7 into 2 numbers. We cannot use 1 and 3 anymore because they are already in Oscar's hands. So we cannot use 1 and 3. We can use 2, 4, but there's at least one number last equal to half of 7. So we have one number last equal to 3. So this number has to be 2. 1 and 3 cannot be used. So 7 equals 2 plus 5. So Aditi has the cards 2 and 5. Next, we consider Raven. Raven, the sum equals 11. So one number should be smaller equal to 5. And for these 5 numbers, we already used 4 numbers, 1, 2, 3, and 5. So this number in Raven's hand must be 4. So the number is 4 plus 7. And actually at this step, we have sufficient information to solve the problem. But let's keep going. We solved Tyron's and the Kim's numbers. For Tyron, we have the sum equals 16. So one number should be less equal to 8. But it cannot be 8 because 8 cannot be used twice. So it should be a number less equal to 7. For the number less equal to 7, we already used 6 numbers above. There's only one remaining number not used, which is 6. So Tyron's number is 6 plus 10. And of course, for Kim's number, we only have 2 numbers remain. That's 8 and 9. In this way, we solved all these card numbers in everybody's hand. Now let's go to the choices. Choice A, Raven was given card 3. That's wrong. Aditi was given card 3. That's also wrong. Raven was given card 4. That's true because Raven's number is 4 plus 7. Aditi was given card 4. No. And the Tyrone was given card 7. That's wrong. So here, the answer is C. Question 18. A failed 6-sided die is repeatedly rolled until an odd number appears. What's the probability that every even number appears at least once before the first occurrence of the odd number? Let's first consider the event that an odd number appears. So we claim that this probability is actually 1, but let's justify this claim. Let me denote AK to be the first odd number appears after kth row. Probability of AK is that we have all the previous k minus 1 rows to be even numbers, and the kth row to be odd number. That means we have, for even number, the probability is 1/2 k minus 1. For the kth row, is also 1/2. This gives 1/2 kth power. Probability of having an odd number is the summation of all these sub events. So it's 1/2. The first row gives odd number. 1/2 square. The second row gives the odd number. 1/2 cube. The third row gives odd number all the way. This summation gives 1. That means we always have an odd number appears. Next, we consider the probability that every even number appears at least once. Now, it's convenient to consider the complement, the opposite events. Consider the complement events. So there are basically 3 cases. 1, there's no even number. No even number appears. 2, there's only 1 even number. Before the odd number. And 3, we have only 2 even numbers before the odd number. Those 3 cases are the complement event. We can calculate each probability. The event, the case 1. So for convenience, let me denote this 1 by event B, this by event C, this by event D. For 1, no even number appears before the odd number. That means we have only 1 row. And this row gives a odd number. The probability is 1/2. The first row gives an odd number. Now, event C, only 1 even number appeared before the first odd number. There are totally 3 even numbers, so we have 3 choices. Three choices for this even number. And before the first odd number, all rows gives this number. So the probability will be 1/6 times 1/2. 1/6 means we have this even number. 1/2 means we have the odd number appears. This is like 2 rows. If it's 3 rows, we have 2 rows gives this even number, this, and the third row gives some odd number. So some odd number, the probability is 1/2. Similarly, we have 1/6 cube times 1/2. That means we have 4 rows. By this argument, we have this summation. And actually, we have 3 choices for this even number. We need to multiply this by 3. This is the probability of event C. This gives 3 times. So the bracket gives a geometric sequence. The summation equals the first term times 1/1 minus the common ratio. The common ratio is 1/6. This is 3 times 1/10. which is 3 over 10. The probability of having exactly one even number before the first odd number is 3 over 10. Next, we consider the event C. We have two even numbers appear before the first odd number. So similarly, we have three choices for this two even number. And let's see, we fix two even number. See, 2 and 4. And next, let's consider the sequence of rolling this die. We have the last roll to give this odd number. And the probability is 1 over 2 because we have three odd numbers. Before this odd number, we will have these two even numbers. 204, 204, 204, 204, 204. And for each row, we get 204. The probability equals 2 over 6, which is 1 over 3. Now let's just take summation of all the number of rows. We should have 1/3 so the probability here is 1 over 3 times, suppose here we only consider all the numbers before the odd number is either 2 or 4. So if it's 2 rows, it's 1/3 times 1 over 2. If it's 3 rows, it's 1/3 squared times 1 over 2. If it's 4 rows, 1/3 cubed times 1 over 2, and add up to infinity. This is not the probability of D. So because we include some invalid cases, we need to subtract two invalid cases. That corresponds to all of them are 2, all number before the odd numbers are 2, or all numbers before the odd number is 4. So there are two cases with only one even number. So we should subtract 1 over 10, 1 over 10 twice. This 1 over 10 comes from the previous step calculation. This is 1 over 10. So we subtract this. So this number corresponds to, we have this 204 both appear before the first odd number. And of course, we should multiply this by 3. That's the probability of a D. This number gives you 1 or 3 over 20. Okay, now we calculate all the complement probability. So answer will be 1 minus probability of B minus probability of C minus probability of D. This is 1 minus 1/2 minus, 1/2 plus 3 over 10 plus 3 over 20. This gives 1 over 20. So the answer to this question is 1 over 20. Question 19. S is a finite set of positive integers. Let's list from the smallest number to the largest number. If the greatest number is removed, the average equals 32. If the least number is also removed, means we remove both least number and largest number, the average of the remaining integers is 35. For the middle numbers, we have the average to be 35. Let's see, we have k numbers in between the least number and largest number. And if we if we return the largest number, the average increase to 40. So the greatest integer is 72 greater than the least integer in S. Let me denote the least integer to be A. And then the greatest integer should be A plus 72. And we have some number in between. This number has average 35. We know that if we just remove the largest number, the average is 32. So this 32 times k plus 1 number. So here we have equation 35k, the sum of the middle numbers, plus the least number equals 32 times k plus 1. And if we add this largest number back to this set, we also have k plus 1 numbers, but this time the average equals 40. So that means 35k plus A plus 72 equals 40 times k plus 1. We have these two equations on A and K. We can solve both of them. Let's solve A. Okay, let's solve K first. 2 minus 1. We can cancel K on the left-hand side. That's 72 equals 8 times K plus 1. Here we can solve K equals 8. And next we can plug in to solve A. Let's say we use the first equation. We have A equals 32 minus 3k, which gives 8. So A equals 8. The question here is to find the average of all the integer in the set. That will be 35k plus 2a plus 72 divided by k plus 2. So 35 times 8 plus twice a plus 72 and divide by 10. And this number equals 36.8. It's basically 368 divided by 10. The answer here is D. Question 20. We have 11 line segments, each of which had length 2. They construct the following pentagon, this shape. We need to find the area of this pentagon. So remember, if we have 3 equal line segments connect to each other, we get an equilateral triangle. So here we have actually 4 equilateral triangle. I'm call this M, this N. So we have a triangle ABM, triangle BCM, triangle AEN, triangle DEN. They are all equilateral. So here the point is to connect A and C. And A and D. We can split this pentagon into 3 regions. Triangle ABC, triangle ADE, and a triangle ACD. We have 3 parts. For triangle ABC, this is equivalent to an equilateral triangle, I mean the area, because it's 1/2 the equilateral triangle plus 1/2 of the equilateral triangle. So let me draw it here. A, B, C, M. We connect AC. This is like divide the rhombus into 2 equivalent equal area. Okay, triangle ABC. This area is 1/2 of the area ABCM. This is equivalent to one equilateral triangle. Okay, and this area, we have formula √3 divided by 4 times the side length square. The side length is 2. This area equals √3. Similarly, triangle ADE is equivalent to triangle ABC in the area. It's also √3. So finally, let's consider triangle ACD. CD is the line segment equals 2. And we can calculate AC and AD. They are equal. So this is isosceles triangle. ACAD both equal to 2√3. That's twice the height of equilateral triangle, 2√3. Because this is 2, this is 1. So this is √3. So it's 2√3. So AD is also 2√3. Next, we can find the height, the altitude from A to CD. Let's call this M. M is, okay, we should change the number, change the notation. We call it K. So K is the midpoint of CD. Equals 1. So 1, 1. So by Pythagorean theorem, we can find the altitude. 2√3 square minus 1 square, and then we take square root. This is √11. And then with the area of triangle ACD is 1/2 the base times the height, which equals √11. So the area of the pentagon equals √3 plus √3 plus √11, which is twice √3 plus √11, which is √12 plus √11. So m and n are 12 and 11. M plus n is 12 plus 11, which is 23. The answer here is 23. Question 21. A square piece of paper has side lengths 1 and the vertices A, B, C, D. The paper is folded, so that vertex C lies on AD at a point C prime. We have a C prime D. That's 1/3. So it's 1/3 of the side length. That means AC prime is 2/3. The question here is to find the parameter of triangle AE C prime. Let's determine the location of the crease. So let me call this point to be F. Let's find where is F. So we denote DF to be X. That means CF should be equal to C prime F equals 1 minus X. So this is 1 minus X. But if we consider the triangle C prime DF, this is a right triangle. C prime D is 1/3, DF is X, C prime F is 1 minus X. The Pythagorean theorem shows that 1 minus X squared equals 1/3 square plus X squared. From here, we can solve X, and so we can determine the location of F. So 1 minus 2X plus x squared equals 1 over 9 plus x squared. So we can cancel x squared and solve x equals 4 over 9. From here, we see the shape of this triangle C prime df. C prime d to df to C prime f. This is 1/3 to 4 over 9 to 1 minus x is 5 over 9. This ratio equals 3 to 4 to 5. It's a typical right triangle. Now we consider triangle AC prime E. Because angle EC prime F is a right triangle, we have that triangle AC prime E similar to triangle DFC prime. This is because we have the same angle. Angle A equals angle D. Angle AC prime E equals angle DFC prime. Both of them equals 90 degree minus angle DC prime F. So they are similar. And they are similar means they have the same ratio for the three sides. That means AC prime, okay, we should start from AE. AE corresponds to C prime D. So AE to AC prime to EC prime, this is 3 to 4 to 5. And now we know that AC prime equals 2/3. So here we can find the parameter equals 2/3 times the sum here is 3, 4, 5 is 12. 12 over 4. AC prime corresponds to 4. So that's the parameter. The parameter equals 2. Answer here is A. Question 22. Ben, and Jasmine each have 5 blocks with 5 colors, and there are 5 empty boxes. So each of the people randomly and independently place one of their blocks into one box. So everybody have 5 blocks, each go to one empty box. What's the probability that there's at least one box receives 3 blocks of the same color? So it's M over N. Let's figure out M over N. So here we consider a general problem. Suppose for these 3 people, they have K blocks. Say K blocks. And of course, K different colors. And there are K empty boxes. So the scenario is similar. Each person places the K blocks into K boxes. What's the probability that there exists at least one box receive 3 blocks of the same color? So here, let me denote AK to be the number of ways to place the blocks such that at least one box receives 3 blocks of the same color. Now, for this case, if each person place 5 blocks into 5 empty boxes, we have 5 factorial. Because we have 3 people, we have 5 factorial cube. In the general case, that corresponds to k factorial cube. That's the total number of ways to place the blocks. Let's see how many ways are there in AK. It's convenient to start from a small number k. If it's A1, each person just have 1 block. There only 1 box. There's just 1 way to place the blocks, and that's valid. The box has all the blocks the same color. That's easy. Now let's consider A2. Suppose we have 2 boxes. Each person has 2 blocks. We have at least 1 box receive 3 blocks of the same color because we only have 2 boxes. So that means both boxes will have the same color blocks. And there are 2 choices for the color. So it's just 2 factorial. That's just 2. A2 equals 2. And next, let's consider A3. We have 3 boxes. Each person has 3 blocks. Now, at least 1 box has all blocks of the same color. The number of such boxes could be 1 box, 2 boxes. If it's 2 boxes, it must be 3 boxes. So if it's 1 box, we should choose which box to have this same color blocks. And then we should choose this color. There are 3 colors. So 3 choose 1. For the remaining parts, it's equivalent to have 2 blocks each person and 2 empty boxes, such that there's no box with same color blocks. That corresponds to the complement of A2. That is equivalent to 2 factorial cube minus A2. This is the case with only 1 box of the same color blocks. We could also have 2 boxes of the same color. That corresponds to 3 boxes of the same color. That's a permutation of 3 colors, 3 factorial. So A3, we can calculate this into 60. So A3 depends on A2 in this way, is 60, because we already have A2 equals 2. And next, we can consider A4. Let's still discuss the number of boxes with same color blocks. If it's just 1 box with the same color blocks, we choose which box and which color. That's 4 times 4. For the remaining part, that's the complement of A3. Because we only have 1 box with same color blocks. For the remaining 3 boxes, there's no same color blocks. So that's complement of A3, which is 3 factorial cube minus A3. And next, we consider 2 boxes with the same color. So we should choose 2 boxes. And then we place 2 colors in 2. We choose 2 colors, right? 1 go to 1 box here. The first box has 4 choices for the color, and the second box has 3 choices for the color. And we have remaining 2 colors and the 2 boxes. That corresponds to a complement of A2. Complement of A2. And next, we consider we have more than 2 boxes with the same color blocks. That there's only 1 case. That means each box has the same color blocks. So this corresponds to 4 factorial. If we have three boxes with same color blocks, that means all boxes with same color blocks. So that's 4 factorial, the permutation of the color. This number is equal to 2,952. So our goal is to find a phi. Suppose a phi. Still, we consider the case that there's only one box with the same color blocks. Phi choose one, which color? Phi choose one, which box? The remaining part is the complement of A4. So 4 factorial cube minus A4. There's no more such box. And next, we consider two boxes. Phi choose 2. These two boxes. The first box has 5 choices. The second box has 4 choices. The remaining part is the complement of A3. So next, we consider 3 boxes. Phi choose 3 times phi 4, 3. And the remaining part is complement of A2. If we have more boxes of the same color blocks, that will be every box has the same color blocks, which is 5 factorial. So here, let's be careful. It's more convenient to keep the common factor. And the answer here is 2/5 times 3 cubed times 5 times 71. And the probability in this problem is basically a phi divided by 5 factorial cube. Totally, we have 5 factorial cube ways to place these blocks. And a phi means the number of ways to have at least one box with same color blocks. This can be simplified to 2/5 times 3 cubed times 5 times 71. And the 5 factorial equals 1 times 2 times 3 times 4 times 5. So this is, we have 9 twos. We have 3 threes. We have 3 fives. So that corresponds to 71 over 2/4 times 5 squared, which is 71 over 400. So Mn are 71 and 400. And plus n equals 71 plus 400. The answer is 471. We choose D here. Question 23. Here is a square with side length 8. And it's colored white except for isosceles right triangle corners. And on the center, we have a black square with side length 2 root 2. Now we drop a coin, a circular coin with diameter 1 onto the square, such that the coin is completely contained within the square. What's the probability that this coin will cover part of the black region? So first, let's find the admissible region for the center of the coin to be dropped, because the coin must be completely contained in the square, so it's at least 1/2 away from the boundary. The coin has radius 1/2, diameter is 1, so radius 1/2. So the distance from the boundary of the square to the center of the coin is at least 1/2. So we will draw a smaller square. This is the region that the center of the coin could lie. Okay, the red region. So each side shrinks to inside by 1/2. So this is a square of side length 7. This is 8 minus 1/2 minus 1/2. The side length equal to 7. So the total red region is 7 square. Total region is 7 square is 49. For this region, we can have the center of the coin could be on any point of this region. Next, we consider the region for the center of the coin such that the coin touches the black region. In order to touch the black region, the distance from the center to the black region is less than 1/2. So here we draw the line that's 1/2 away from this black region. So basically, I draw this part 1/2. So it's 1/2. So maybe let me draw here. So what I mean is this distance is 1/2. If the distance is less than 1/2, the coin touches the black region. Similarly, we also have for the center part, this is also distance 1/2. Distance 1/2. Distance 1/2 to the 4 sides. To have distance less than 1/2 from this corner, this corresponds to a sector. This is a sector on the 4 corners. Small sector on the 4 corners. It's a quarter sector. Degrees for 90 degree. And still for the 4 corner, we have this distance 1/2. Distance 1/2. So as long as the center of the coin lie on this region, this red region, this red region, the coin will cover part of the black region. So let me call this way, the valid region is the red region in the picture. Now let's calculate the area of the red region. It's divided by 49, that's the probability. First, let's calculate the corner part. So I will just draw a part of this corner. This is side length. This is an isosceles triangle with these 2 sides equals 2. And this red piece. We shrink by 1/2. And here we draw the distance 1/2. The red line is 1/2 from the hypotenuse of the isosceles triangle. So basically, we can calculate this distance. Let me call this A, B, C, D. CD a midpoint of the corresponding hypotenuse. So we need a BD. BD equals AD minus AB, which is AC plus CD minus AB. We know AC equals √2. And the CD equals 1/2. And AB equals 1/2 root 2. So BD actually equals root 2 over 2 plus 1 over 2. So each corner, the area is the corner red region has the area equals BD square, which is 3 plus 2 root 2 divided by 4. And actually we have 4 corners. We just multiply by 4. That's the 4 corner region. Four corner regions equals 3 plus 2 root 2. And next, we consider the central part. The central part, let me draw a picture. The center square with side lines 2 root 2. And we extend this by 1/2 on each direction. So we can consider this region has 3 types of region. The square part, and this 4 rectangular part, and the 4 sector parts. Let me call this blue sectors. So the center region is center red region. Consists of three parts. The first part is the square, the original square, black square, which is 2 root 2 square. The second part is the 4 rectangular region. 4 times the length is 2 root 2. The width is 1/2. We have 4 pieces, so that's the region. The third part is the 4 sector region. They make up a complete square. Sorry, they make up a complete circle. So this pi times 1/2 square. That's the total area in the center. This is 8 plus 4 root 2 plus pi over 4. That's the center red region. Now we add up these two numbers. Total valid region equals 3 plus 2 root 2 plus 8 plus 4 root 2 plus pi over 4. This gives you 11 plus 6 root 2 plus pi over 4. And now the probability is 11 plus 6 root 2 plus pi over 4 divided by 49. And let's simplify it. This equals 1 over 196 parentheses 44 plus 24 root 2 plus pi. And we know AB, so A plus B equals 44 plus 24, which is 68. The answer here is 68. Question 24. So Arjun and Beth play a game by removing bricks from a wall. Each time a person could remove 1 brick or 2 adjacent bricks. So Arjun plays first. The person who removes the last brick wins. The question is here, for which of following starting configuration there's a strategy for bats to win. Okay, let's think about how to win this game for a person. So here's the point. So Arjun or bats will win if the following happens. If after his or her her turn of removing bricks, the remaining bricks, the remaining walls has a symmetric structure. So here, symmetric structure means that we have a pairs of pieces. They have the same shape. This symmetry means there are even number of turns. Symmetric structure guarantees even number of turns in the future, and that will guarantee the last turn is this person. So let's take an example to show this idea. For example, we can take A. So we have we start from 611. For A, Arjun has the strategy to win because he can, after his turn, he can make the structure symmetric. For example, we can move. We already have two ones. We can split 6 into two twos. Basically, he just removed the middle two bricks, so the wall becomes 2 2 1 1. So this is symmetric. This is what I mean here. And after this, Arjun has control to make the number of turns to be even, because in the future, no matter what bats moves, Arjun just do the same. Because the shapes, we have pairs, Arjun can always do that. So the strategy here is A, just do what B did in the previous step. Okay. Say B removes 1, A can also remove 1. B can remove 2, A can also remove 2, because we always have these pairs. So there will be even number of turns. So finally, Arjun wins. That's for A. So let's apply this idea to other choices. So actually, C, D, E is easy to see. Arjun has this strategy to win. Let's discuss C, D, E. Let's see, C, we have a 6, 2, 2. Here, Arjun can make the symmetric as follows. Still, Arjun remove the middle two bricks. So it will be 2, 2, 2, 2. Same strategy. Okay. And next, D, we have 6, 3, 1. Arjun can make this symmetric. He just remove 2 bricks from 6 to make it 3, 1, 3, 1. So this is symmetric. And Arjun just do what bats did in the previous step. And E, same for E. This is 6, 3, 2. So we just make a pair of 3, 2. So he can only remove 1 brick from six brick walls to have a 3, 2, 3, 2. In the future, so let's check what Beth did. Arjun just follow her movement, her remove. So Arjun just do what Beth did in the previous step, and he will be guaranteed to win. Now let's check B. For B, Bass has a strategy to win. B is 6-1. Let's discuss B. What's Bass's strategy? B will have 6-1. There are different cases, and in each case, Bass has a strategy to win. No matter what Arjun do in the first step, Bass always has a strategy to win. So for example, Arjun can remove one brick from 6. It will becomes 5-1. Okay, the first step is by Arjun. And he removed one brick. There are several cases. It could be 4-1-2-1. It could be 3-2-2-1. So that's 3 cases that Arjun removed one brick from the piece with 6 bricks. And if Arjun removed 2 bricks from the piece of 6 bricks, he can get 4-1. He can get 3-1-2-1. And also 2-2-2-1. So these are cases Arjun removed 2 bricks from 6. And Arjun can also remove 1 brick from 2. That's 6-1-1. Arjun can also remove 2 bricks from 2, so it becomes 6-1. Arjun can remove 1 brick from 1, so it's 6-2. So these are all cases Arjun can produce. And next move is Bass. Bass try to make the symmetric to guarantee her win. So now with Bass can have the following strategy. She can move 2 bricks from 5 and to get a 3-2-1-2-1. And in the future, Bass just do what Arjun did in the previous step. So for this picture, we can remove 2 pieces from 4 to get a 2-1-2-1. It's symmetric. Here we can remove 1 brick from 3. It's 1-2-2-1 is symmetric. Here we can get we can remove 1 from 4, so it's 2-1-2-1 symmetric. Here we can remove 1 brick from 3, so 2-1-2-1 symmetric. Here Bass can remove 1 brick from 2, so it's 2-1-2-1. So 1-2-1 symmetric. And here also she can remove the middle 2 bricks, so it will produce 2-2-1-1 and symmetric. For all those cases, Bass in the future step, Bass just observe what Arjun did in the previous step. She did the same in the next step. B do what A did in the previous step. So for the last 2 cases, it's a little bit subtle. Bass cannot just remove something to make it symmetric. So let's see, here we needed one more step. So for example, here the Bass strategy is she cannot make it symmetric, but she can do some intermediate step. So she need to make sure Arjun cannot make it symmetric next time. So what Bass can do is to make the both cases can use the same configuration. You can go to 3-2-1. For 6-1, Bass just remove 1 brick from 6. You will 3-2-1. For the second one, 6-2, Bass just remove 2 bricks, so it will be 3-1-2. So they are equivalent, okay? And next is Arjun's turn, right? Let's see what happens. What can happen to Arjun? There are still several cases, but each case Bass can resolve it. So if Arjun remove 2 bricks from 3, so 1-2-1. Remove 1 brick from 3 is 2-2-1. He can remove one break from 3, so it's 1, 1, 2, 1, the middle break. And he can also remove one break from 2, 3, 1, 1, and just the whole 2 breaks, so it's 3, 1. Or he can remove the last one break, so 3, 2. So let's see, we list all cases here. This is for Arjun. So let's check if we miss any case. Okay, I think we have all cases included. Yeah, and now what Beth can do is to make it symmetric. This time she can make it symmetric because like for first one, she can just take 2. She can just take 2. So it becomes 1 and 1. So there are two more turns. Beth will win. And here she can just take 1. So it becomes 2 and 2. Here she can take 1 from the 2. So it's 1, 1, 1, 1. Here there will be 4 more steps. And here she can move 1 from the 3. So it's 1, 1, 1, 1. Here she can just remove 2 breaks from 3. So it's 1, 1. So we want to make it symmetric. Here she can remove 1 break from 3. So it's 2, 2. So in the future, there will be only even number of turns. So finally, Beth will win. So this is the complete strategy for Beth. So our answer here is B, 6, 2, 1. Question 25. We consider lattice point in the coordinate plane with coordinates between 1 and 30. And we draw a line with y equals mx. There are exactly 300 points on or below this line, and which find the range of this slope m. Let's first try to estimate the value of the slope. We have this coordinate system up to from 0. Okay, we only consider positive coordinate values. 30, 30. And there are totally 30 square, which is 900 lattice points with positive coordinates. Now, 300 lattice points takes 1/3 of the total number. If we want to estimate this m, the slope, we basically draw a line such that 1/3 of the area is below this line. So the slope corresponds to 2/3. So if m equals 2/3, 1/3 of the area is below y equals 2/3x. So that means that m is approximately 2/3. It's around 2/3. That's some estimate. Now let's check how many points are on or below the line if m equals 2/3, and then we can adjust if necessary. So consider m equals 2/3. So let's see how many coordinate lattice points are on or below this line. Number of lattice points on or below the line y equals 2/3x is, so we consider x value from 1 to 30. If x equals 1, So okay, here let's first use general notation m for the slope m. If x equals 1, y equals m. Then we take the integer part. That means that corresponds to how many number of y coordinates or integer, positive integer. If x equals 2, y equals 2m, and we take the integer part. That's the number of lattice point on this line. Similarly, we consider 3m. That's the line x equals 3. How many lattice point on this line? Below the y equals mx. So the total number of lattice point is the summation up to 30m. Okay, here we take a specific m equals 2 over 3. We plug in. Two times 2 over 3 plus 3 times 2 over 3 up to 30 times 2 over 3. So here we have a pattern because m equals 2 over 3. If the integer added by 3, we just add a number of integers. Say we have am and okay, a plus 3k times m. This corresponds to am plus 2k. And the 2k is integer, so it's simply am plus 2k. In other words, we have 4m equals 4m integer part equals 1m integer part plus 2. 5m integer part equals 2m integer part plus 2. 6m integer part equals 3m integer part plus 2. And so on. So this is the pattern. This helps us to simplify the calculation here. So we only need to find the first 3 terms. So the first term gives 0, 1, and 2. So the next term will be 0 plus 2. So we'll group this into several groups. Each group have 3 terms. So it's 1m, 2m, 3m. This is the first group. Next group is 4m, 5m. Here m equals 2 over 3. 6m. And next group. So the first group has the sum equals 3. The next group, well, each term is increased by 2. So this is 3 plus 6. The next group has the sum 3 plus 6 and plus 6. So it's 6 times 2. Totally, we have 10 groups. The total number of lattice point is 3 plus 6 plus 3 plus 6 times 2. 3 plus 6 times 9. Totally, we have 10 groups. So we have totally 10 times 3 plus 6 times 1 plus 2 up to 9. This is 30 plus 6 times 45. This is 30 plus 270, which is 300. We have exactly 300 lattice point on or below y equals 2 over 3x. Okay, that means 2 over 3 is the minimum valid slope. Okay, let me first state of course, there are lattice point on the line. For example, we have a 0.3, 2, and then 6, 4, up to like 30, 20. These are lattice point on the line. So that means this m is the smallest valid slope. Now we need to find what's the limit of the slope. In other words, what's the largest slope? Of course, we cannot achieve the largest value because it touches the next largest point. So next step, we find this limit, the upper bound of the slope. I'm sketch here. We have a line with slope 2/3. So next, we increase the slope. We increase the slope. Oh, this is steeper and steeper until we touch the next lattice point. Increase slope from 2/3 until the line touches the next lattice point. So this m will be the limit of the slope because we require to have exactly 300 lattice point. So we should not include next lattice point. Next lattice point. Okay, mathematically it means that we should have find a lattice point somewhere. Maybe it touches here. That's the next lattice point. Suppose x coordinate is I. The y coordinate is j. That's the next lattice point. Y equals mx. Here m is larger than 2/3. J over I is larger than 2/3. And the I, j are between 1 and 30. We need to find the minimum such slope. Smallest value of j over I. That's the upper bound of the slope m. Okay, let's discuss I. So here I has three cases. If I is a multiple of 3, because here we have 2/3, so we discuss the remainder when I is divided by 3. If I is a multiple of 3, so say I equals 3k, the smallest, this fraction larger than 2/3 will be 3k here. On the top, it's larger than 2k because the ratio is larger than 2/3, so larger than 2k. But we want the smallest such number, so we just be either 2k plus 1. That's the smallest fraction of this form. And to minimize this value, we will take minimum value is okay, is k equals 10, because if k is larger, the fraction is smaller. So to minimize the value, let's take k equals k. K equals 10 implies the minimum value equals 21/30. This is the smallest case when the denominator is a multiple of 3. And next, this denominator could be 3k, say plus 1. The smallest value has the form 3k plus 1 in the denominator, something in the numerator. The fraction is larger than 2 over 3, so the smallest numerator should be 2k plus 1. This is already larger than 2 over 3. And we also want to minimize, okay, we have different case. We want to minimize the fraction. We take k equals 9. That implies the minimum value equals 19 over 28. That's the smallest value of the second type. Third, if I equals 3k plus 2, still the smallest value equals, in the denominator is 3k plus 2. The numerator should be larger than 2 over 3 of the denominator. So it's 2k plus 2. 2k plus 1 is still too small. 2k over 2 over 2k plus 2 over 3k plus 2. That's larger than 2 over 3. And then to minimize this, for all k, we take k equals 9. That gives you minimum value to be 20 over 29. So these are minimum values in different cases. And finally, we should take the overall minimum value. And it should be the second one, because it's easy to compare. This is like 1 minus 9 over 30. This is 1 minus 9 over 28. This is 1 minus 9 over 29. The second one is the smallest. This is overall minimum. So the upper bound of the slope m is 19 over 28. So that means the interval for the slope is between 2 over 3. 2 over 3 is included, but 19 over 28 is not included. This is left part is closed, the right part is right end is open. This is the interval we look for. And here we find the length of the interval. It's 19 over 28 minus 2 over 3. That's 84 in the denominator, 1 in the numerator. So a plus b equals 1 plus 84. This value is 85. So in this problem, we have the answer equals 85. We choose E here. Okay, that's all solutions to this AMC10B. Thank you for watching.